going to present in English since when I get nervous I have to test to swallow words, and Swedish words are a bit bigger than English words, so there's a shaker has it. Swedish. So this is titled my presentation. That's my name and my Twitter handle. I'm going to talk about different ways to build a Java backend. I'll start a short introduction. I will tell who I am and why I'm doing this talk. I will explain about different frameworks. I am going to compare today, show some code. Then I will show some comparisons, lines of code and so on, and actually have a conclusion. And if you have any questions, feel free to interrupt me in English or Swedish, whichever you prefer. So who I am and where to start. I'm primarily a BI expert. What does the job signifies? So BI expert, left me on training in Belgium. Also a cook. Cyclist. And a geek who likes to go to conferences. In my spare time, I work as software developer for a company called Tetrapack, which I think most of you have heard about. We do mostly food packaging, mostly milk. We also have an IT department, which is why they employed me, where we develop some software, mostly for internal use. I work on something called P2. P2 is an application that's used by all operators in all our factories to track production, report errors, measure quality, measure waste, create reports, and so on. P2 is quite an old application. We started developing it 10 years ago, so it's built on fairly old technologies like EGB2 and so on, Swing. It's web and mobile unaware. We don't really have any mobile client. We only have fat Swing clients. And we know that we will need to have a mobile solution sooner or later, because the management wants to have fancy toys, iPhones, iPads, and so on, and they want to be able to know what happens in the factory. Since doing something like that based on a current solution would be a bit complicated, calling EGBs from iPhone is painful, and creating something on top of our current solution would require us to conform to our current long development cycle, ask the look at alternatives. What can we do that's small and simple that we can put next to our existing solution that will just present some data? So I decided to look at those three frameworks. So here we have Java E7. It's the latest version of Java E that we all know and usually hate, some of us love. Spring, that's also quite an old well-known framework that a lot of people either love or hate, and sometimes both. And relative newcomer, Dropwizard. So let's start with short version of Java EE. Java EE has been around since 1998. The first version was called J2EE. We're no longer allowed to use that term, according to Oracle marketing people. The new term is Java EE. Java EE used to be extremely verbose, with a lot of XML and a lot of extra interfaces to get everything done. During the last few versions, it has become much more developer-friendly. We lost a lot of XML, we lost a lot of extra interfaces, and it's overall much nicer system to work with. Java E application to one application server, and there's a number of different solutions for that. For the latest version, Java E7, that was released a year and a half ago, there are currently 3 alternatives. There is Glassfish, that's an FS implementation. There is Wildfly, That's the new name of JBoss open source version. And that is Tmax Juice, which is relatively unknown application server, but they have been the first one to have a commercial Java implementation for the last few releases. It's a South Korean company, and they mostly use South Korea. I'm not sure why. Spring was developed starting 2002 by Ron Johnson and then a lot of other people. It started out as a set of libraries on top of Java EE, but it became an alternative. And in some ways, it can even be part of Java EE implementation. For example, right now we are using WebLogic 10, and WebLogic 10 has a lot of Spring inside it as part of its EGB implementation, for example. Spring started out much less verbose than Java EE. If we look at the latest versions, they are more or less equal. And well, it all depends who you ask. If you ask Java EE evangelists, they will say Java EE is much better. Spring will say that Spring is much better. Truth somewhere in between. Dropwizard is a relative newcomer. The first version was delivered in 2011, but it gained mindshare quite fast. It reached, according to ThoughtWorks, that's a large technology consultancy that publish technology radars now and then. It reached trial stage in October 2012. Which is basically, you should look at it and play around. And it reached adult status in January this year, and that basically means that if you have something where it seems like a good solution, use it, because it's good, stable, useful. Dropwizard, well, that's code for a website, a little bit of implemented glue code, which bands together a set of libraries which have historically not sucked. And those libraries are JS for RESTful web services, it's Hibernate for database access, Jackson for JSON, and a couple of others. So let's look at the code. What I've implemented is a small to-do application. I will start with a small demo of one of the versions, and then we'll look at the code. So let's see if I have a working server somewhere. Yes, I have a working Dropwizard, and I have running localhost. So right now we have no people in there are two tables, people and tasks, and there are corresponding REST requests. So let's create a person, and that would be a small RESTful call. I'm using curl for put and post, and I will show it in browser gets. So I create a user, let's create myself, let's create another user, and that's my good twin, and let's give me a task. Drink beer. So now we have two people, Pavel and Pavel, but you can see it. Now you can see it. And we can look at one person, and we can look at tasks for that person. So it's a fairly simple application with varied functionality. I didn't do a front end for that because if you looked at my front end, you would lose all trust in my ability as a developer. Let's look at the code, and let's see if we can zoom it in some nice way. Let's see if it will be. It will disappear. Okay, so I think that's readable even from the back. And I have a couple of entities here. Person entity, that's standard JPA, nothing weird. And let's see. We have a task, also JPA, weird stuff, same as all our JPA implementations. Well, it's Hibernate. We have some resources. Let's look at one of them. That's a person resource, and that's one that I was using. Then here we have a couple of notations. Where it will be served, but there's JSON, a couple of methods that annotate with get and put to show what calls we can make with quite simple implementations. Unit of work is a Dropwizard notation that signifies it's a transaction. All of that is driven by those two classes, configuration, application. Use configuration to see if I have a database that I'm using, and it's really simple. That's the application that binds all together and connects a resource with DAOs. And I haven't looked at the DAOs yet, so let's look at one of those. That's to do DAO. Abstract DAO is a base class that we get from Dropwizard. It gives us some basic persistence methods, like list, which gets all the items that fulfill certain criteria. I'm using it for find all here, and here I'm using it for criteria for to list all tasks that the person is responsible for. Persist, get, so most of the methods are quite self-evident what they do. It's built using Maven. We have here 3 different dependencies. Dropwizard core, that's the most important one. You need to do anything with Dropwizard. Dropwizard Hibernate, that's if you want to use Hibernate today for database access. They have another solution also that's much more JDBC-like. And since I ran this on Oracle, I ran it Oracle because I had a working Oracle installation on my computer. I didn't want to play around with other stuff. It uses, I have Oracle driver here. There is also a plugin for building a fat jar file. I will talk a bit more about that later. There is also a configuration file, which is yet another markup language, and that's my Oracle configuration. Basically how to access this, and that should create database when needed. That was Dropwizard. Let's look at Spring Boot. And that. And yeah, that's pretty much it. Spring Boot can be built using both Gradle and Maven, and probably other ways also, but Gradle and Maven are described very well on their website, and Gradle is the preferred way, from what I understand. So this is my build script that we see here. It's shorter at least than the Dropwizard one, but that's mostly because Gradle is a less verbose solution than Maven. We have 2 entities that look exactly the same. Here we have no data access objects, here we have 2 interfaces instead. And Spring Boot knows what to implement. It knows its Oracle database, so it can generate all the relevant queries by itself if I extend cloud repository. So I get all create, read, update, deletes automatically. For tasks, I need an extra method, find by responsible. and here all I need to do is implement the method. As long as I follow the naming convention, my database column is called responsible. As long as I follow the naming convention, then Spring knows what it should do with the method, how it should implement. I also have a couple of controllers, so let's look at one of those. So that's my person controller, that's the one corresponding to the one I showed in Dropwizard. So here we have certain different annotations. Here we do not have a constructor that injects database repository tasks. Here we have dependency injection using AutoWired, which is standard Spring way to inject stuff. Also we have slightly different annotations, as I probably said just before this, but it's more or less the same otherwise. All of it is driven by an application class that looks like this. So here I have just a few annotations and a main method. Annotations tell Spring how it should configure stuff. So here I'm telling that I want JPA repositories, that I would use JPA, and that what allows it to create implementation for those classes. Components can tells it that I am going to use REST controllers, controllers, and can scan for those also. And the other two tell us that if I have configured something, it should do it by itself. It should figure out how to do it and do it for me. So I don't have to worry about those things. There is one properties file, and it's also for my Oracle configuration. It's smaller, I'm not sure why. Java EE solution is also very similar. So here it's built using Maven, and here we have under one dependency Java EE API. That's all that's needed to create Java EE applications. As long as you do not use anything outside Java EE, and usually you do. For example, you frequently need Archillion for testing. But normally Maven, normally ponds for Java EE should be quite small. We have entities that look exactly the same, except for here we have a named query. Java EE does not provide the same convenience abstract class like that Spring and Dropwizard provides, so there are no abstract DAOs and no current repositories. So here we need to slightly work by ourselves, and here I created a name query for my find by person. We have resources that look quite similar to the ones we had for Dropwizard, since it's same JS implementation, but here we inject entity manager using persistent context instead of injecting DAOs using constructor. And we use we need to have query builders for queries. All of it is driven by this little class. That's all configuration that I needed for this, and it basically tells Jersey that I have professional resources that I want to deploy at resource application path. And as I said earlier, it needs to be deployed on the application server. Yeah, and I also have persistent XML for to tell that I'm using JPA. I'm not sure why I need that. I shouldn't do that. So that was the code. So let's go back to the presentation. And drop this on to that. Well, let's look at some metrics. Amount of text is probably the most interesting one, since that's a pretty good approximation of how much work you do as a developer to get it to work. So here we can see that Dropwizard was the most of those solutions. Not by much, but still. Java EE and Spring are more or less equal. Spring has slightly less Java code, and Java EE has slightly less of other stuff. But Java EE also has some configuration of application server, the data source pod, which would correspond roughly to these 14 lines. Build times are also quite low, with Dropwizard being the slowest. Java EE is this fast only because what I'm building here is a war, so the jar file. I will talk about that a bit later. But they're still quite small for all cases, and well, the times from this machine, which is quite powerful. Binary sizes. Dropwizard and Spring Boot are jar files that can be run from the command line with Java jar. So they include a container. Java is just a war, so it's much smaller. But if you are going to center the network to deploy somewhere far away with slow internet connection, then 8 kilobytes is much nicer than the other versions. Deployment options. Java EE is war-based, so you can do almost anything in it. If you go back to old versions, then you couldn't have database access in a WAR file, so you need to have separate jars, and then you need to put it all in an EA file if you wanted to have a lot of other stuff. These days you can do almost anything in WAR. I'm not sure if there are still any cases where you actually need an EA file or something more complicated. For Java EE, you can build fat jars so that you embed the entire application server in your jar file. It's complicated and not a very good solution. So when I've been researching this, I searched a bit on the web, and I've seen people claim that they got it to work and it worked well, but the guides were a bit complicated to follow. Spring Boot, the normal way is to build a fat jar. And that works very simple. You can build a raw file, and it can be done very easily. You just change a couple of parameters in your Gradle configuration. Raw files will be quite big, since they need to include all the libraries. So Hibernate, Jersey, Jackson, whatever you're using. So they would be quite big. Not as big as the number we saw here, but still quite big. Dropwizard fat jar is the default, and that's the supported version. You can make war files. There's a project called WizWar, but that's from their homepage. So it's only works on certain Tomcat 7, Tomcat 8 might not work, and other application servers. Some features are supported, some features are tested, and it's not a bad idea. So you could do it, but well, you shouldn't. We'll need documentation sometimes. We don't want to admit it, but we don't usually need it. And let's see, we don't have it here actually. Yeah, Spring Boot has also documentation. Spring homepage has a lot of tutorials that tell you what to do line by line, you almost don't need to know Java to be able to follow them. As long as you're able to install JDK and download things from the internet, you can follow tutorials and build worked applications. Of course, to do anything meaningful, you do need to know Java and be able to, and know some JPA and some Jersey and so on. But tutorials are awesome and very easy to use. There is also a lot of auto-completion on the web. Googling for anything, Spring, you will almost always find a good answer really fast. Java EE also has quite good documentation with a large number of books and tutorials and guides. A lot of them provide source code. Often that source code is quite hard to follow if you're not an expert already. For example, I looked at Java EE 7 samples GitHub project that was developed by Aaron Gupta, who formerly was Oracle's Glassfish guy and now is Red Hat's Wildfire guy. He developed a lot of very good tutorials with hopefully simple implementation of various features. But when I looked at his POM, it was around 1,000 lines. And when POM is 1,000 lines, you should need to be an expert to understand what it does, what's used, what's not. So I found it a bit hard to use. But there's a lot of information on the web, and most of it is quite good. Dropwizard has a good homepage, where most things are explained, and quite easy to follow. But since it's a much smaller framework with less following right now, Googling for it is not as useful, and sometimes you run into weird issues that are hard to get help with. Unless you email the creators, and then you always get help if they try to answer. When you're done developing your application, you will need to go to Ops, and Ops runs the issues all the time, so they need Ops features. For Java EE, it depends on the application server. And there it's very different. For open source ones like Glassfish and Wildfire have some, which are quite good. If we go up to the expensive ones like WebLogic or WebSphere, then there's a huge amount of stuff you can do. You can change almost anything about your application and monitor anything. Of course, you need to use all of that, but there's a lot of things available. Spring Boot has some by default, and it's fairly easy to add more stuff. So let's see if I can do a small demo. And let's see. Actually, I can't do demo for Spring Boot. I can do demo for I'll do Dropwizard first. So, Dropwizard also has some features, and I'll also do a demo. I have Dropwizard running right now, so I'll do that first. So, Dropwizard. By default runs on port 8080. Port 8081 is for Ops. And here we get by default 4 different links. We get some metrics, and that's a lot of JVM info, garbage collection, heap size, and so on. Some information about Jetty. So a bunch of that data that could be interesting. We also get information about every call at command line, and you probably can read it, but then information about how long every call takes and how many JDBC connections are used and what they do. Yeah, but from web you can do ping, and you get POM if it works. You can do thread dump. It's really useful debugging too when things don't work. And we have health check. So then we have healthy deadlocks and healthy hibernate, which is quite nice. So let's stop Dropwizard and start doing good. And let's see how long this takes. Normally, when I'm not doing presentation, it takes around 5 seconds. When I'm doing presentation, it takes 20. I'm not sure why. So when we started, we get a lot of information here, and again, you probably can see, but here we have a lot of different links to various admin features. So let's look at something, for example. So this is config information. The automatic part. Not particularly useful, but a lot. You get information about HTTP calls if we go to case. So we had a call from somebody who uses Chrome, probably me, and we got JSON back and 200. We can get some metrics, hopefully. So you had so much sheep, using so much. We had 17 threads peak. I'm not sure why that many. And we have that many classes. Most of them, I don't know what they do. I remember there was like 10. We get information about environment. So back we're using Windows, since it's featured in certain places. And I'm running Java 8 from Oracle. But basically there's a lot of information, and some of it is really useful. But it all depends on what you're looking for. So, statuses, if we go to health, statuses update, Oracle hello is hello. First I was doing this, I did not prepare for that question. Didn't expect it. I'm not sure why. When I started doing this, I actually expected Dropwizard to be the best, since it's been used the youngest and so, especially for small use cases, because that's its primary purpose, to build small things. But once I actually wrote the code and looked how long time it took me and how much I needed to actually learn to use it, I felt it was the worst, because it required the most code. That's probably because Spring Boot, for example, learned a lot from Dropwizard. Again, while Googling for information for this talk, I found a lot of facts where from the time when Spring Boot was something new, like a year and a half ago, where it was seen as a copy of Dropwizard. And it might very well have started that way. Spring is old, but Spring Boot is a fairly new implementation. Java EE has become much less verbose in the last few versions. If I would have done the same in Java EE4, for example, then I would have like 5 or 6 more XML files, all of them quite large, a couple of interfaces and so on. But these days it's a reasonable competitor to Spring. Spring or Java EE? Well, it depends. If standards are important to you, if you want to be able to go to vendors like Oracle, IBM, Red Hat and so on, or giants, then Java is very good for you. If you want faster development and more new features faster, then Spring is probably a better idea. Spring has support out of the box for things like NoSQL database like MongoDB and Neo4j. It has support for a lot of other things that are not part of Java EE yet. Some of them will be in the next version, but that's 2 years from now. So, for most cases I would probably choose Spring Boot, especially for small ones. And that's what I have to talk about. Questions? Suggestions? Opinions?
What's the difference between a Spring Boot and Spring normal?
Well, Spring Boot is a different way to package applications. And the Spring Boot moves a lot of configuration from XML files and so on into something magic. Basically, the Spring Boot, the fun part is the pattern notation, which is do magic. I think it would much better name. Yeah.
Om du skulle köra igång ett lite större projekt med säg 5-10 utvecklare eller plus uppåt. Är det en poäng att använda någon av de här Java EE idag? Vinner man så mycket på det för större typer av utveckling? Eller?
Det är en bra fråga. Jag vet inte om det finns någon data på detta. Men jag skulle inte gå på Dropwizard. Jag tycker att den kan för lite för stora projekt. Men Spring, ja, mycket väl. Sen om man vill, det beror lite på vad du vill ha för features. Om du vill ha NoSQL, typ MongoDB eller Neo4j eller vad du vill ha, då är ju Spring jättebra. För då får du allt out of the box och saker funkar ihop med varandra på ett bra sätt. Om allt du vill ha är det som finns i Java EE, då är det jättebra att göra det. Så jag ser det är en smart sak. Om utvecklingsprojektet kan Spring så kör Spring. Om utvecklingsprojektet kan Java EE kör Java EE. Om de kan varken eller ta myntkasta.
Du frågar ju om precis som XML att man behöver ha den vidare i toppen. Det är 2 år sedan jag utvecklade JPA, men då satte vi i alla fall upp databaskonfigurationen i den tillsammans med vilka entiteter som vi skulle jobba med. Eller de skulle vara snabba. Jag vet inte om man har ändrat det.
Ja, nej, men det kan man, men den som jag har är tom. Och det funkar inte utan den. Eller, det funkar inte senast jag testade. Det kan ha hänt något de senaste 2 dagarna.
Det är fortfarande upp till en container där.
Ja.
Jag menar att man kan även lägga sin databaskonfiguration i sin container.
Ja.
Eller då har den sidan och då fyller den här filen mer funktion.
Ja, precis. Man kan ju overrida lite annotations också. Man kan göra saker där. Så den är bra att ha egentligen. Men verkligen också där filen, till exempel WebXML, de har blivit optionella. Och BeansXML har också blivit optionell i senaste versionen. Så jag vet inte om det är så att jag har visst tryckt på någon knapp för att det ska bli optionellt. Eller om det kommer i nästa version. Eller, ja, jag vet inte.
Are there any other contestants that you looked at except for Dropwizard?
No. I knew there are other frameworks, but I needed to limit myself to something.
Mm.